So here's another dilation video. I'm going to work through an example, and what I've done is I've put up our steps to solve these problems. And what I'm going to do is I'm just going to make this a little smaller so we have room to work, and I'll put it up in the corner so you can refer to it, but it won't be in the way. So here's our dilation problem. We've got A prime, B prime, and C. And what we want to do is find where C prime is going to end up. So I'm going to follow our steps right above. So for step 1, we need to find the equations of those lines from A to A prime as well as the line from B to B prime. So let's just start with A to A prime. If we want to find that line, we need to find its slope. So that's going to look like 10 minus 1 over 5 minus 2, 9 over 3, or 3. And since we have a point, we can just throw it right into point slope form, 3x minus 2. So there is the line, the equation of the line from A to A prime. So now let's do B to B prime. And we'll give that a, okay, so the slope is going to be 14 minus 2 over minus 11 plus 2. Looks like 12 over negative 9, which is going to be a negative 4/3. Y minus 2 equals negative 4/3 x plus 2. So now I've got a system here with this line and this line. And what I'm going to do is I'm going to solve the system using substitution. So I'm going to come back up here, and I'm just going to add 1 to the other side on this top equation. So I'm going to get y equals 3x minus 2 plus 1. And that's going to get substituted in. So now what I'm going to do is just make this a little smaller so you can still see it, but so we have room to do the other parts of this problem. And now we're going to find the center. So that's going to be step 2, using a system to find the center. So step 2, we've got this solved for y. So we're going to plug it in for this y. And that's going to look like 3x minus 2 plus 1 minus 2 equals negative 4/3 x plus 2. And I'm going to do a simplification step here on this left side. So 3x minus 2 minus 1 is negative 4/3 x plus 2. And what I like to do here is to get rid of the fractions. So what I'm going to do is multiply everything by 3. And what that does is I get 9x minus 2 minus 3 is negative 4x plus 2. So I've lost the fraction there. I'm going to distribute 9x minus 18 minus 3 is negative 4x minus 8. And then if I add my x's to the left side, I'm going to get 13x minus 21 is negative 8. So 13x is 13 and x is 1. If x is 1, then we can go over here, and since we'd solve for y in that top equation, y must be 3 times 1 minus 2 plus 1, which is going to give us negative 3 plus 1, or negative 2. So my center is going to be 1, negative 2, and I guess we've been calling our center O, so we'll call that O. Okay, so now I'm just going to make this smaller. Put it up here so you can still see it, but we're going to move on. And let's do part 3. So we're going to find the magnitude. So the magnitude is going to be the distance from O to A prime over O to A, which should also be the same as O to B prime over O to B. So we can just find one of them. So let's do O to A. So that's going to look like the square root of, and we're doing O to A prime. So 10 plus 2 squared plus 5 minus 1 squared over the distance from O to A, which is going to be 1 plus 2 squared plus 2 minus 1 squared. And if you crunch that into your calculator, it spits out 4. So our magnitude is 4, and we are done with step 3. So let's take that, shrink it down, and we can put it right over here. So there's our step 3. So now step 4, we need to find the vector from O to C. So from O to C, we would call that this vector, OC. And that's going to be the components of C minus the components of O. And remember, O is 1, negative 2. So that's going to look like negative 1 minus 1, 3 minus a negative 2. So that's going to give us negative 2, comma, 5. And that's it for step 4. So let's shrink that down a little bit. We'll put it right here for step 4. Now for step 5, what we need to do is find the vector C prime, and the way we do that is multiply our vector OC by the magnitude. So what it's going to look like is we're going to do magnitude times this vector, which we just found, which is also going to look like 4 times negative 2, 5, or the vector negative 8, 20. So that's my vector from O to C prime. So I'll write equals O to C prime. Okay? And we'll just shrink that up. Put it right there. There's 5. And now for our grand finale, to do step 6, what we need to do is, that's our vector, but we need to tell it where to start, right? Otherwise, it just ends up starting at 0, 0. So we need to tell it to start at O. So what we're going to do is we're going to do O plus the vector OC prime. And what that looks like is 1, negative 2, plus negative 8, 20. And that's going to give us a point at negative 7, 18. And that is C prime. So we found C prime, and there's all your steps.